Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Raining 10 Clues by Patrick Junke, or Junk, I'm not sure how you pronounce it, or Junke, maybe it's Junke, I don't know. Anyways, here are the rules. We have normal Sudoku rules apply, which means place the digits from 1 through 9 in every row, every column, and every 3x3 region. We have standard killer cage Sudokus, where in dotted regions, digits don't repeat and sum to the indicated total. In this puzzle, always 10. So for example, these, they're always 3 cells, and therefore you don't have repeats in these 3 cells, and they must always add up to 10. So you could have something like 1, 4, and 5, and that would be valid for the killer cage. What you could not have is something like, say, 4, 2, 4, because you have a repeat in this cage, and that's not allowed. It does add up to 10, though, but that's all. We also have an X between 2 digits indicate they sum to 10. So, for example, if this were, say, a 3, this would have to be a 7 to add up to 10. And all X's are given, so that means there's a negative constraint involved too, where if you have, say, a 3 in this space, that means no 7 can be in the spaces that share an edge with it, because they would have to have an X in between them if that were the case. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Let's see if we can find places which have X's next to them. Because 5 can never be next to an X, because it would have to be 5 plus 5, adding up to 10, in normal Sudoku. These have an X next to it, this has an X next to it, this has an X next to it, this has an X next to it. So 5 in column 4 has to be one of these 2 cells. Okay. X, 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 X. So 5 in column 9 must be one of those 2. X and X. X. In box 9, 5 has to be one of those 3. Okay. X, 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 X. So 5 has to be in box 5, one of those 2. So the possibilities of 3 unique digits adding up to 10 are 127, 136, 145, and 235. So to have 2 X's add up to a 10, with both of them in a 10 box, it has to be either 3, 7 or 4, 6. Right? If either of these are 7, it becomes 1 and 2. Okay. All 3 of these... Okay, so all 3 of these are next to an X in this 10 box. So this cannot contain a 5. So it's either 127... 136, or, yeah, that's it. 127 or 136. So this is 127 or 136 with a 1 guaranteed here. These are all next to X's. So again, it's 127 or 136. So if it's 127, this is 7. If it's 136, either of these could be 3 or 6. So this cannot be 4 here. This cannot be 6. And all of these digits are next to an X digit. So again, it cannot... So this is 127 or 136. Which means this can't be 4. This can't be 6. This is guaranteed to be a 3-7 pair. You have 1-2 with it, or 1-6 with it. Therefore, you have a guaranteed 1 here, so this cannot be 1. Which means the 1 has to be here. So this is 1 and 9. This is 2 or 6 with the 3 or 7. 2 or 6 would have to be with 4 or 8, which makes that with 2 or 6. 1, 2, or 6 has to be with 4 or 8 or 9. And this is 4, 8, or 9. It cannot be 9 here, so this can't be 9 and 1. Therefore, where is the 1 in this cage? It must be here. So this is 1, which makes this 9. That leaves the remaining digits in column 4 as 4, 5, and 8. That means none of these can be 4 and 6 or 2 and 8 because we already have a 4, 5, 8 triplet in the box. So this must be 1, 3, 7, 9, and this must be 2 or 6 here. Okay. That eliminates 1 from this cell, so this cannot be 1. That means this is either 2 with 8, 3 with 7, 6 with 4, and 7 with 3. This could be 1 and 9, 2 and 8, 3 and 7, 6 and 4, and 7 and 3. So those are the possibilities. Okay, what does that mean? This cannot be 1 and 9, adding up to 10. Oh, this has to be 2, 3, 5 triplet because you don't have a 1 available in this box. So the remaining digits in this box are 4, 6, 7, 8. Okay. Either this is 1 and 9, or this is 1 and 9. Either way, this can never be 1 and 9. So it could be 2, 8, 3, 7, or 4, 6 here. Okay. So either this is 9 or this is 9, which means you can't have a 9 in the rest of this box, but we already knew that. 9 has to be one of these 3. One has to be one of these 2 digits here. So either this is a 1, which would force this to be 2, 7, 3, 6, or 4, 5. Or this is 2, 3, 5. So those are the possibilities there. These 2 digits can never be either of these sets because they would have to contain both of these. So it cannot be 1, 9, or 3, 7. It has to be either 2, 8, or 4, 6 here. Interesting. Okay. Huh. I was hoping that I could do some coloring, but basically that's not happening. We also have the negative constraint too. Okay. What are these possibly? They cannot be 3, 7 because of the 3, 7 pair in the box. 1, 9, 2, 8, or 4, 6. This can't be 1, so this can't be 9. This can't be 1, so this can't be 9. Right. Huh. 1 and 9. Okay, so 5 has to be one of these 2 cells. If this were not 1 and 9, the problem is, where would the 1 and 9 be? They couldn't be here, they couldn't be here, they couldn't be here. So that would not be possible. So 1 has to be one of these 2, and 9 has to be one of these 2, which means this cannot be 9. 2 and 6 must be with 4 or 8 to add up to 10. So this is 5, 4, or 8. This is 5, 4, or 8 also. Okay. If this were 1 here, this would have to have an x in between them. So this is not possible to be 1 and 9 here, because we have a guaranteed 9 in one of these two spaces. So where is the 1 then in row 4? It has to be here. So this is 1, which makes this 9. This can no longer be 9, because that would have to have an x in between those. This can't be 1 and 9. So this must be a 9 here, which makes that a 1. So this cannot be 1. This cannot be 9. These digits cannot be 1 and 9, or 3 and 7, because they both see these cells. This can't be 1 or 9. This becomes a 3-7 pair, which eliminates 3 and 7 in the rest of the box. So this is a 1-9 pair. That means 3 and 7. Where are 3 and 7 in column 2? Well, if this were 3 or 7, you'd guaranteed have a 3 or 7 on either side, which would mean there would have to be an x in between. So this must be 3, 7 and 3, 7 here to not have an x in between any of these cells. That means this digit is the opposite. So these two add up to 10. Therefore, either these two add up to 10 or these two add up to 10. So this is either 5 or it's 4 or 8. Because it must add up to 10 with that, or it must be a 5. These two or these two add up to 10. Okay. This cannot be 1, 9 or 3, 7, so it must be 2, 8 or 4, 6 here. This we don't know have anything about. Could be 1, 3. This digit must add up with the other digit to add up to 10. That's not with the x's, right? These are all x's, so this adds up to 10, this adds up to 10, this adds up to 10. So this must add up to 10 with one of these two. Therefore, where is the 1, 9 in column 9? It has to be here. So this is 1 and 9. 1 can no longer be here, cannot be here, cannot be here or here, so it must be here. So this is 1 with either 2, 7, 3, 6, or 4, 5. We don't know which. So this is a 1, 9 pair here. Okay. 9. 9 is one of those 3. 9 cannot be here. 9 cannot be here. 9 cannot be here. 9 can't be next to the 1, so 9 has to be here, which means this cannot be 9 there. Okay. 2, 7, 3, 6, or 4, 5 here. That's still all possible. Okay. Okay. We are guaranteed one of these cells one of these pairs has to be 3, 7, right? Either this is 2, 7, which forces 3 and 8 to be here, or this is 3, 6, which forces this to be 4, 7. So you cannot have a 3 or 7 in the rest of this box. So that leaves what? 2, 4, 5, 6, and 8. 2, 4, 5, 6, and 8. 2, 4, 5, 6, and 8. Okay. This is 5 adding up with 2, 4, 6, or 8 because this cannot be 2. This adds up to 10 with the other digit here. So we're guaranteed a 3, 7 here or here. We're not sure which. We have a 2, 3, 5 in box 4, which is only in rows 4 and 5. We also have a 3, 7 pair in box 5, which is only in rows 3, 4, 5. Sorry, rows 4 or 5. That eliminates 3 from the rest of rows 4 or 5. So this cannot be 3, 7. Where is the 3, 7 in column 9? It has to be this cell. So this is a 3, 7 pair, which eliminates 3 and 7 in the rest of the box. This can't be 3. Where is the 3 then in row 6? It has to be here. So this is 1, 3, and 6 adding up to 10. That eliminates 6 here, so this is 2 and 8 adding up to 10. That eliminates 2 and 8 in the rest of the box. This cannot be 4 and 6 because of the 6 in the box. So this is a 2, 8 pair, which eliminates 2 and 8 in the rest of the column. So this must be a 4, 6 pair here. This 6 eliminates 6 here, so this is 4, which makes that 6. This can no longer be 6, and this can no longer be 6. This 6 eliminates 6 here, which means this can't be 4. We have a 2, 3, 5. Okay, so we know where's the 7 in row 6. It has to be one of those two cells. That eliminates 7 in the rest of the box. We know where is the 2 in row 6. It must be one of these two cells. That eliminates 2 in the rest of the box. So this can't be 2. This can't be 8. We have a 2, 6, 2, 6 pair in row 6, which eliminates 2 and 6 in the rest of the row. So this can't be 6. Okay, remaining digits in column 8 have to be 5 and 7. So this can't be 5 here. This becomes a 5, 7 pair. That eliminates 5 and 7 from the rest of box 9. So this cannot be 3, 7. It can't be 1, 9, 4, 6. It must be 2, 8 as a pair. Since this is 2, 8, this cannot be a 2, 8 pair because that would eliminate all possibilities here. So this is 4 and 6. This can't be 4. This can't be 4. We have a 5, 8 pair in column 4, which eliminates 8, 5 and 8 in the rest of the column. So this is 4, which makes both of these 6. 6 must be add up to 3 to add up to 10. This must be 7 and 2, which makes this 8. That eliminates 8 from this cell here. This 6 eliminates 6 here, so that's 2, which makes this 2 and 8. So this has to be a 4, 5 pair left in the box 5. That means this cannot be 8 here because of the 8 in the box or column. We have 2 here, 2 here. 2 cannot be here. So if this is 1, 2, 7, 7 would have to be here, so this can't be 7. We have... Okay. All the ones. Okay, so this leaves this digit as a 3. This 6 eliminates 6 here, so it's 2. We have a 4, 6 pair, a 1, 9 pair in row 9. Is that helpful? Not particularly. Remaining digits in row 7 could be 1, 9, no 2, 3, 4, could be 5, 7, and 8. This cannot be 1, 8, or 9 because of the 1, 8, 9 in the column. We also have a 4, 6 pair in column 3, which eliminates 4 and 6 in the rest of the column. So this is either 1, 2, 7, 1, 3, 6. So 1, 2, 7, 1, 3, 6, 1, 5, 4, or this is 2, 3, 5. It cannot be, so this is still the same. Never mind. Okay, We have 5 or 7 here. We have a 5, 7, 5, 7 pair in row 7, which eliminates 5 and 7 in the rest of the row. Therefore, we have an 8 guaranteed here. This is a 4, 6 pair. We have a 3, 7, 3, 7 pair in row 3. So that eliminates 3 and 7 in the rest of the row, so that we have just 4, 5, 6, and 9 remaining in row 3. And this can't be 9 because of the 9 in the column. Remaining digits in box 2 are 4, 5, 6, and 8. 8 cannot be here, therefore 8 is guaranteed to be here. This is 4, 5, or 6. Okay. Remaining digits in column 7 are 4, 5, or 7. 7 cannot be here. We have a 4, 5, 4, 5 pair in row 3, which eliminates 4 and 5 in the rest of the row, so that's 6. This can no longer be 5. This is a 2, 3 pair, which eliminates 2 and 3 in the rest of the box, which makes this 5. And the rest of the rows, this can't be 2, that's 8, which makes that 2. This cannot be 4, 5 because of the 4, 5 pair in the box, so this must be a 7. This can't be 6 or 8, so it's 4, which eliminates 4 in the rest of the box. This is 7, 8 as a pair. 4 eliminates 4 here. 5 eliminates 5 in the rest of the column. Okay. This cannot be 7 because there would have to be an x in between them. So this must be 5, which makes this 7. 5 eliminates 5 here, so it's 7. This 6 eliminates 6 here, so it's 4 and 6. This 4. Remaining digits in column 3 are 2, 3, and 5. Well, this cannot be 2 because of the 2 in the row. So this is a 3, 5 pair. This cannot be 2, 3, and 5 anymore, because that would eliminate all possibilities for that cell. So this must be 1 with something. So it's 1 with 2, 7, 3, 6, or 5, 4. So this can't be 3. This can't be 1. This 1 eliminates 1 in the rest of the column. Let's see. We have a 4, 5, 6 triplet in row 1, which eliminates 4, 5, 6 in the rest of the row. This can't be 5. This has to be either 2, 3, or 7 here. Interesting. This is 2, 7, or 3, 6. If we have a 2, can this ever be 7 is kind of the question. If this is 7, that forces this to be 3, which would make this 2 and 7 to add up to 10, but that's not possible, so this cannot be 7. We have a 2, 3 pair in row 1 and box 1, which eliminates 2 and 3 in the row in the box. So this can't be 3. This is 7, which makes this 3, which makes that 7, which makes that 3. This 3 eliminates 3 here, so it's 5, which means this can't be 5. This 5 eliminates 5 here, so this is 4. So this 4 eliminates 4 here, so it's 5, which makes that 4, which makes this 5, which makes that 4. This 5 eliminates 5 here, so it's 4, which means this can't be 4, this can't be 4, and these can't be 4. We have a 5, 6 pair here. This 4 eliminates 6 here because that would have to have an x in between them. So this is 5, which makes this 6, which makes that 5, which makes that 6. This 6 eliminates 6 here, so it's 9. This can't be 6 or 9, so it's 4. Okay. This can no longer be 5. This is 6, 7 as a pair. 6 and 4 cannot add up to 10 and be next to each other, so this must be a 7, which makes this 7 and 2. That makes this 3 and 6. 2 eliminates 2 here, so it's 3. 3 in the corner because we celebrate, because we know we're close to solving it. This 3 eliminates 3 here, so it's 2, which makes this 3. This 7 eliminates 7 here, so it's 8, which makes that 7. 8 eliminates 8 here, so it's 9, which makes this 1, which makes that 9. 1 eliminates 1 and 9 here, so it's 8. Remaining digit in column 2 is a 2. 2 eliminates 2 here, so it's 8 and 2. 8 eliminates 8 here, so it's 5 and 8. 9 eliminates 9 here, so it's 1 and 9. 7 eliminates 7 here, so it's 3 and 7. That leaves this as a 5 and this as a 1. And that's the solution. Oh, after the rain, a rainbow. Nice. Yeah, this didn't really seem that challenging to me. I don't know. Seemed very intuitive. It was very cool. A very nice puzzle. Very nice use of the X clues and the 10 clues. Maybe I'm just so used to these now that basically it's fairly trivial for me. But this was easy for me. This is even... It was between easy and very easy for me, so I don't know. I probably would rate this as easy. Maybe if you're not that used to, like, figuring out what these could be, like, that these... The only real break-in was basically figuring out that any set that had 3 X's next to all the digits meant that these had to be 127 or 136, obviously. You can't have 145, and you can't have 235. So you're guaranteed a 1 in one of these, which meant this had to be 1, so that trivialized that. This had X's next to it, so it's 127, 136, and similar things there, so, yeah. So since this is 1 and 9, this couldn't be 1 and 9. That forced this to be 1 and 9, so 1 had to be one of these. And it's just figuring out where the 1 9s had to be, right? I don't know. Seemed fairly straightforward to me. Was it straightforward for you guys? I don't know. Let me know if you guys found this rather easier than a normal challenging puzzle. And I hope you enjoyed this solve either way, and I'll see you next time on Frank Puzzles. Take care.